Welcome to the second lecture on measures of location. Our learning outcomes are to find the modal class in a grouped data set and to estimate the mean and median for a grouped data set. Since the data is grouped, instead of a mode, you can only find a modal class. To find the modal class, you need to find the class with the highest frequency density. But if all the classes are the same width, then this will just be the class with the highest frequency. Let's look at an example. Find the modal class for this data showing the heights of various shrubs. And in this example we can see that all the classes are the same width, 10 centimetres actually. So this means that the modal class will be the class with the highest frequency. And we can see that the class with the highest frequency is this one, 29, a frequency of 29. So the modal class is the class of 31 to 40 centimetres. Now let's think about the mean and the median. If you have group data, you can only estimate the mean and the median. This is because grouping means you no longer have the exact data values. Now previously, to find the mean for ungrouped data, we used this formula. X bar equals the sum of f times x divided by the sum of f, where f is the frequency and x is the data value, an exact value. But we don't have exact values of x, so what are we going to do? We're going to assume that every piece of data in a class takes the value of the class midpoint. And remember that the midpoint is a half times the lower boundary plus the upper boundary. Let's look at an example. The heights of a number of trees were recorded. The data collected is shown in this table. Find an estimate of the mean height of the trees. Okay. So we need to add the following to our table. We need a row for the lower and upper boundaries. We need a row for the class midpoints. A row for the values of f times x, where f is a frequency and x is the midpoint. And a column for the totals, the sum of the frequency f and the sum of f times x, frequency times midpoint. Let's do that. Now in this example, you can see that actually we have gaps between our classes. So this means that we are going to use the midway between the classes for our boundaries. We can see here the midpoint will be 5.5, 10.5 and 15.5. So in terms of our upper boundary here, we've got 5.5 and lower boundary here also 5.5. And we can fill in these upper and lower boundaries. Now the first lower boundary, remember this is a special case starting at 0. We know that heights can't normally take negative values. Well, they can't take negative values. But for consistency, our lower boundary here is going to be negative. It's going to be minus 0.5. Our last upper value for consistency will be 20.5. Now our class midpoints, remembering our formula that we want a half times the lower boundary plus the upper boundary. So for this first class, we have a half times the lower boundary plus the upper boundary. So actually this is 5, isn't it? So a half of 5 is 2.5, and that will be our class midpoint. We can then repeat the same formula for the remaining midpoints, and then we need to do f times x, well 2.5 times 26 is 65. So f times x for the first class is 65. So we can complete the rest of the table. We also need our totals here for our totals for our frequency and our f times x. And here are the answers. Once we have the totals for the sum of f and the sum of f times x, then we can substitute it into our mean formula for x bar, and we can see that we get 452 divided by 60 to give us an answer, a mean, estimated mean of 7.53, and that has been rounded to 2 decimal places, dp for decimal places. So that's an estimate for the mean. What about an estimate for the median? Let's remember what we've done before. Previously, to find the median, we found n divided by 2 and then decided on the position of the median depending on whether n was odd or even. Once we knew the position of the median, then we knew exactly what the median was because we had exact data values. Let's cast our minds back to our previous example for ungrouped data. And as you can see, we've got exact values. So to find our median, we took our total, n, 100. We would have said, yes, n is even. Divide it by 2 to get 50. And because n is even, that means we are interested in between the 50th and the 51st position. And we decided that the 50th and the 51st are both in this class here. So because we have exact data values, both the 50th and the 51st number are both 2. So that gave us an exact value for the median of 2. But this time we've got grouped data. We don't have exact values. So we need to do something different. And this is called linear interpolation. And this is a method of estimating the value of the median using our boundary values for the class. It's best seen using an example. So here's an example. The length, x millimetres to the nearest millimetre, of a random sample of pine cones is measured. The data is shown below. Find an estimate of the median length of the pine cones to 1 decimal place. And we already have the cumulative frequency. So first of all, we need to find the position of the median. We can see from our cumulative frequency that we know that n is 70. So we can say that 70 divided by 2 is 35. Now previously, what we would have done is considered whether n was odd or even. But this is where we do something different for grouped data. For grouped data, when finding the median, we always take the actual value of n divided by 2, whether it is an integer or a decimal. So considering that, we need to know, well, where is n divided by 2? And we said n divided by 2 was 70 divided by 2, which is 35. So in which class is the 35th number? Well, we can see from our data that actually the 35th number, if this class goes from the 28th to the 57th number, then the 35th number must be in here somewhere. So it's in the class of 34 to 36. We know it's in there somewhere, but what is it? And this is the linear interpolation, where we're going to use the boundary values. If we consider our class 34 to 36, we do have gaps in our classes, so we need to use the 0.5 values for our boundaries. And the boundaries of this class are 33.5 and 36.5, and we know our median M, is in there somewhere. But what else do we know? We also know the cumulative frequencies, the boundaries. So we've got a boundary of 27 and a boundary of 57, and we actually want the 35th number. And we're going to look at the ratios between these two sets of numbers. If we consider A divided by B, then because it's the same interval, that must be the same as C divided by D. And what we end up with is, let me just change my colour. What we end up with is this equation here. A divided by B must equal C divided by D. Well, we only have one unknown in that equation, and that's M, so we can solve this for M. So substituting in A, we can see A is M minus 33.5, B is 36.5 minus 33.5, C 35 minus 27, and D 57 minus 27. So put those numbers together, A divided by B equals C divided by D, we end up with this equation here. And all we have to do is rearrange that and solve it for M, and we find that M equals 34.3. So our median value, our estimate for the median value is 34.3. And we can check to make sure that this is within our required class. And of course, 34.3 is between 34 and 36. So we have checked our answer. Now let's look at another example. Estimate the median length of the newts described in this table, rounded to 1 decimal place. Again, we have grouped data. We do have gaps between our data. And we can see that there is a total of 37 pieces of data altogether. So n divided by 2, 37 divided by 2 is 18.5. So we are interested in the 18.5th data value. Remember, for grouped data, we just take n divided by 2. But where is the 18.5th value? Let's look at the cumulative frequency. And we can see from this that the 18.5th value is actually going to be in this class here. Yeah? Because this class contains the numbers, the 4th number to the 21st number. So 18.5 is in that class. Now we need to do the linear interpolation using our boundary values. And our boundary values, if I just go back a slide, we can see that for this class, our boundary values, we have gaps between our data. So we're going to have 2.5 lower boundary, 5.6, 5.5 as our upper boundary. And the boundaries for our frequency, we're going to have, let's change the colour again. Oh, let's have purple. Yes. Our boundary values for our frequency are going to be 3 and 21. So set up the diagram, and here we have it. So our our boundary values on our data, 2.5, 5.5, boundary values on our frequencies, 3 and 21, using the actual value of, let me change that, the actual value of n over 2, which was 18.5. So now all we have to do is substitute into our equation a divided by b, or in this case a1 divided by b1 equals a2 divided by b2. And you can see that we get this equation here. Rearranging and simplifying and rounding to 1 decimal place as required, we find that our estimate of our median is 5.1 centimetres. So you've seen some examples, now have a go at the question.